Read the question carefully. A production facility is capable of producing 80,000 widgets in a day, and the total cost of producing is given by this function. This is the total cost function. How many widgets per day should they produce? So that means x equals what in order to minimize the production cost. So we need to minimize this cost function. And what is the minimum production cost? After we find this x, plug in here and we find the minimum cost. Okay, in any case, whenever we are trying to find maximum or minimum, we need to find critical numbers. That is, we need to find the derivative of the given function. So here let's find derivative of this c. Derivative of 0.67x is just that 0.67 plus derivative of that number is 0 plus something over x. So the derivative is, let me show you one thing. When we have some number over x, that is same as c times, move this up, x raised to -1. So finding a number over x, derivative of number over x is same as this one, and that derivative constant is just constant. We can use the power rule, xn. So n x n minus 1, -1 minus 1, c times -1 is negative c x raised to -2, which is same as negative c over, because negative exponent means on the bottom x squared. So you need to know this fact so that we don't have to write a lot of steps. A constant over x, derivative of constant over x is negative the same constant over x squared. You can get the same answer by using the quotient rule. Constant, the derivative of constant is 0. Okay, we could have used that. So constant over x, then its derivative is minus constant, the same number, 16,750 000 over x squared. Okay, so that's the derivative. Now we set the derivative equals 0 to solve for x. That means critical numbers. So this fraction, this one plus 0 is just that, minus this equals 0. 0.67 minus 1675k over x squared equals 0. So we are trying to solve for x. So we got a fraction, a number. Let's move this fraction to the other side. So this is 0.67 equals, this negative means we are adding this fraction, 1675 thousandths over x squared. Now this is a fraction, we can make this as a fraction and cross multiply. So this one times x squared is 0.67 x squared equals 1 times that number is just that. Now 0.67 times x squared, so divide by 0.67, then we get x squared equals 16,750k, that means thousands, over 0.67. Use your calculator. That gives 25 million, 250 million. Okay, that's x squared. But we are trying to find the value of x. So x squared equals that. Let's take x, that's the square root of this. So we take the square root of both sides. So x equals, we get plus minus when we're solving. That is 1, 2, 3, 4, 5, 6, 0 means 3, 5. So you can use your calculators as 5,000 plus or minus. And if we look at go up, x is the number of widgets, so it can be negative. So we just take positive. So 5k. Okay, that's the x value. Now we want to evaluate the cost. This is the total cost function at the critical number and at the end of the intervals. The intervals are not given, but read the question. this is capable of producing 80,000 widgets. So the maximum is 80,000. That's the cap, and minimum is 0. Okay, so let's do it. Let's evaluate the function. So let me do over here. So X and the cost function. So X is 5,000, that's the critical number we found, and endpoints 0 and 80,000. 80,000. In fact, for 0, this is undefined, because the cost function, if we look at here, something divided by X is undefined. Now 5,000, replace, plug in X equals 5,000. So 0.67 times 5,000 plus 250,000 plus that number over 5,000. Use your calculator, you're gonna get 256,700. Okay, now plug in 80,000 here in the same function. If you plug in, you get 303,809, and from these three we can see this is the minimum cost, and that happens at 5,000. So to produce the minimum cost, to get the minimum cost, production cost, they have to produce how many widgets? 5,000, and the total minimum cost is this. So there can be two answers, so two parts. So the number of widgets per day is 5,000, and the minimum cost in dollars 256,700 final.